we are looking into the concept of subset. So the name makes it very clear actually. What does sub mean? The general meaning of sub. Anything? Yes, part of. Okay, sub, one of the meanings which we can derive is part of. So let's look into the word subset. Just a second. Yeah, let's look into the word subset. Set A is a subset of B. When do we tell set A is a subset of B? If and only if every element of A is in B. For example, if you're not able to understand that, let me show it to you guys. X is set of all the students in your school. So X has from kindergarten roll number 1 to 12th grader roll number say 50, 52. Okay, let's look into Y. Y is set of all students in your class. So say you guys are in 11th grade, so 0, 1 to 11, 0, not 0, say 48 students are there. Now, what can you tell about set Y? Set Y is said to be a subset of X. Does it make sense? See, X contains all the students in your school. By default, it will contain the 11th graders as well. Is it not? So by default, set Y will be part of set X. So Y is said to be a subset of X, part of X. There's no one left out from Y. Is it not? Does it make sense? A has 1 to 7 elements, while B has 1, 2, and 4. What can you tell about A and B? A is a subset of B. Is that correct? A is a subset of B. Clearly not. So we have B, which is a subset of A. A better way to kind of visualize this is over here. So we have A is a subset of B if and only if every element of A is in B. So whatever is in A is part of B. So B is this huge circle. Okay, so we have A to be within that B. Right? So there is a lot of aspect that we need to understand. We're just getting introduced to the idea of subset. Okay. So one more way of representing whatever we understood is over here. We have a program which will visualize whatever we understood. So we have set A and set B. Set A is made up of 1 to 7 and set B is 4 to 1. Right? The same example. So when I happen to run this, what do we get? We have a circle and another circle. So within the circle are all the elements in set A. And within this brown circle is all the elements in set B. So by default, with that idea, can we tell that whatever is in set whatever is in set B is part of set A, because A has this circle itself. So 1 to 4 is by default part of set A, because 1 to 4 is indirectly pointed towards set A. Is it not? I hope it made sense. Don't worry, if not, we are going to learn it in detail in time. Or let me show that now itself. So let me add an element which is not part of set A in set B. So I'll add 100. Okay. So let me execute this. So you can see that set B, which is made up of this circle. So we clearly see that some of the elements in set B and A are common, while 100, which is part of set B, is not in set A. So here set B is not a subset of A. Okay, set B is not a subset of A. Right? So symbolically, this is how it will look. So X is a subset of Y, while B is a subset of A. Sorry, I made a mistake. This is supposed to be Y, subset of X, and B is a subset of A. So this is how you represent subset, a sleeping U. So I have a quick question for you guys, because it's a very simple concept. Every set is a subset of itself. That's the assertion I'm making. The reason behind that is because every element in a set is considered a member of that set. So read the definition of subset and try to conclude if the assertion and reason are correct, and if the reason explains the assertion. And I have another question, sorry. Here the assertion is an empty set denoted by that is a subset of any set. Reason, because all elements of an empty set are included in any set. Does it make sense? Think. The answer for both is assertion and reason are correct, and the reason explains the assertion. So let me summarize it over here. So we had note 1, an empty set is a subset of every element. So it's quite simple. Say I have a set A, it is made up of A, E, I, O, U. Then we can tell that the subset, sorry, not subset, 0, null set is a subset of A, because what are the elements in null set? Nothing, right? So is it there in A? Yes. There's nothing in null set, so that is present by default in A. Because we are looking for nothing, so we have nothing over here also. Of course, we have this. Along with that, we have nothing as well. Because we are not searching for anything, is it not? Right? So by default, what? Because every single element of null set is also an element of A. As per the definition, it makes sense. See, point is, whatever element is there in null set, is it there in A? Kind of, because there's none in null set. So by default, it's also there in A. Because we're not searching for anything, by default, it's there in A. Okay? If you're still confused, just remember that null set is a subset of any given set. It's an important fact, and you guys do get questions based on that. The weird note 2. A set is a subset of itself, because whatever element is there in A, by default it's there in A, is it not? Right? So yes, every element is a subset of itself. So you guys have to remember this. I already introduced this concept, that is not a subset, right? So till now we have been studying about subset. Now we're looking into something which is not a subset. So we have A, set A, which is 1, 2, 3, and set B, which is letter A. So can we tell that A is not the same as B, or B is not the same as A, and also A is not a subset of B and vice versa? Is that correct? Because whatever element is there in A is not in B. So it can be this also. It's not like, I need to have something else altogether different. Even this 3 is not present in A. Sorry, the number 3 is not present in set P. Okay, so we can give some reasoning like this, as 3 belongs to A and 3 does not belong to B, right? A is not a subset of B. Okay, similarly, what can you tell? As 4 belongs to B, and 4 does not belong to A. B is not a subset, sorry, this is a symbol, not a subset of A. Okay, so what is the symbol? This is your symbol. So I'm going to summarize it over here. Not a subset. How do you go about writing the theory? So we have something like this. So we have considered sets A, which is A, E, I, O, U, and B, which is A, B, C, D. Here A and B are not subset of each other, right? So A is not a subset of B and B is not a subset of A. How to present the answer? So I have written over here, A is not a subset of B and B is not a subset of A, as E belongs to A and E does not belong to B. Also, we have D belonging to B and D does not belong to A. Because of this reason, I can conclude the following. Okay, guys. So yeah. So this would be your concept. So it's quite simple. I kind of gave a lot of example. So if not, it's not that complicated. 3 sheets, it looks to be big, but it's not that complicated. The only confusing part I feel is this weird points, So this is where you guys might mess up. The second point is quite simple. Subset is and how do I put it across? A set is a subset of itself. Yeah, a set is a subset of itself. So this is quite simple actually. I think this I'll give 2 stars. This you might forget. Okay. So you guys can pause and see to that you write the information that will make sense to you guys. Don't just copy.